Hi, I'm Bob. In the Cournot model we discussed last time, both firms announce their output decisions simultaneously. But in practice, one firm may act before the other. It is true when one firm enters the market before the other firm. In this situation, we use the Stackelberg model. The assumptions of the Stackelberg model are as follows. First, we assume there are only two firms in the market. It is called duopoly, a type of oligopoly with two firms. Second, we assume that firms choose their quantity of output instead of price. Third, one firm chooses its quantity of output before the other. The firm that acts first is called a leader. The firm that acts later is called a follower. The follower observes the leader's output level and then decides its own output level. Fourth, we assume that the market lasts for only one period. Each firm chooses their quantity only once. Fifth, we assume that both firms are identical. They have the same production cost, and they produce identical products. Sixth, both firms have complete information. They know each other's possible strategies and the corresponding profits. The payoff function or profit function is common knowledge. We see that the only difference in the assumptions between the Stackelberg model and the Cournot model is the timing of the firm's action. The two firms act simultaneously in the Cournot model, but they act sequentially in the Stackelberg model. We use the same market demand function and the firm's cost function in the Stackelberg model, so we can compare the equilibrium quantity and profit in the Stackelberg model to those in the Cournot model later. The market demand is Q equals A minus P. The inverse demand function is P equals A minus Q. The market output Q is the sum of the quantities of the two firms. Q equals Q1 plus Q2. So the market price P can be written as a function of Q1 and Q2. We also assume that the firms have the same constant marginal cost C, and their cost functions are C1 equals C times Q1 and C2 equals C times Q2. We first consider the follower's choice. Here we adopt a method that is often used in game theory to solve sequential games. It is called backward induction. Backward induction is a process in which we first determine the best response by the last player to move. Next, determine the best response for the player who make the next to last move, and then repeat the process until we reach the first move of the game. In the Stackelberg model, we have only two firms. We work backward from the follower and determine the follower's best response, and then we consider the leader's choice. For the follower, the second firm, its profit is equal to total revenue minus total cost. That is P times Q2 minus C2. Plug in the expressions for market price and the firm's cost. And then we use the first order condition. The partial profit over partial quantity is equal to 0. It is equivalent to the profit maximizing condition. marginal revenue is equal to marginal cost. Rearranging the equation, we can find the follower's best response function. The follower's profit maximizing output level, Q2, depends on the leader's output level, Q1. This best response function is exactly the same as the best response function in the Cournot model. Next, we consider the leader firm's choice of output level. The leader knows that the follower's quantity of output relies on its decision because it sets quantity first and the follower sets quantity later. So the leader will take it into account and choose an output level that maximizes its profit. For the leader, the market price P is no longer a function of Q1 and Q2. It is a function of only its own quantity, Q1, because the follower firm's quantity depends on the leader firm's quantity, which is what the follower firm's best response function shows. The leader knows the follower's best response and replaces the follower's output with the follower's best response function. In this way, the market price can be written as a function of the leader's output level. The leader's profit is equal to total revenue, that is market price times quantity minus total cost. The profit function contains only one variable, the leader's quantity of output. To maximize its profit, the leader chooses the output level that satisfies the first order condition, or marginal revenue equals marginal cost. We can solve for the equilibrium quantity of the leader's output. It is equal to 1/2 times A minus C. From the follower's best response function, we obtain the follower's profit maximizing output level, which is 1/4 times A minus C. The leader's output is twice the follower's output. Now we have the two oligopoly firms' equilibrium quantities, so we can calculate the market output. It is the sum of them. It is equal to 3/4 times A minus C. The market price can be found from the inverse demand function. It is equal to 1/4 times A plus 3C. We could also compute the profits for the leader firm and the follower's firm. The leader firm's profit is 16 times higher than the follower firm's profit. We find that if the Stackelberg leader chooses its output before its rival, the Stackelberg follower, the leader produces more and earns a higher profit than the follower. It is an advantage to act first. Next, we compare the results between the Stackelberg equilibrium and the Cournot equilibrium. Suppose the market demand and the firm's cost are the same in both models. The leader firm in the Stackelberg equilibrium produces more than each firm in the Cournot equilibrium, which is higher than the follower firm's output in the Stackelberg equilibrium. The Stackelberg market output is larger than the Cournot market output. The Stackelberg price is less than the Cournot price. Thank you for watching this video and subscribing to my YouTube channel. See you next time.